let's continue talking about vocabulary and notation in this video, and that will hopefully finish setting the stage for solving some examples in the next one. Now, if we go back to the previous video, we saw that whenever we do a hypothesis test, that we have two hypotheses. And we have a null hypothesis, and we have an alternate hypothesis. Now, you should also know, from this point forward, our focus is again going to be on means and proportions. So when we have those hypotheses, the null and the alternate, they're often going to involve mu's and p's. For instance, let's pretend that I've got a null hypothesis involving a mean, and that null would be in the form, my population mean is equal to some number. And I'm just choosing 35 as some arbitrary number right now. So if a null is in the form, the mean is going to be equal to some number, then the alternate can actually take on one of three different forms. You could have an alternate hypothesis that would look like this, where the mean is less than 35. You can have an alternate hypothesis like this one, where the population mean would be greater than 35. Or you could have this one right here, where the population mean is not equal to 35. This is called a left-tailed hypothesis test. This one is called a right-tailed, and this one is called a two-tailed. And the names actually will make a lot of sense to you as we dig into this, because we're going to be working with a normal distribution again. And when your alternate hypothesis is this, then you're typically working on the left side of that normal distribution. When your alternate hypothesis is this, you're typically working on the right side, hence the names left-tailed, right-tailed, etc. Okay, so let's take a look at some examples here, and we'll set up our hypotheses. And that's actually going to be one of the most important things that you do in a lot of these problems, is properly set up the null and alternate hypotheses. So example 1, I said last year, the mean amount spent by customers at a certain restaurant was $35. The restaurant owner believes that the mean may be higher this year. And so if that's the case, isn't the owner or the researcher hypothesizing that the mean is going to be greater than 35? But the null hypothesis is the one that suggests no change. And so the null hypothesis is that the mean is still going to be 35. The alternate hypothesis, that is our researcher's hypothesis, that would be the mean is greater than 35. And so going back to what we were just looking at, this would be called a right-tailed hypothesis test. Example 2. In a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of newborn girls differs from this. So we have to really start paying attention to the language that's used in these problems, because that impacts how we set up our hypotheses. So the null hypothesis here is going to be that there is no change, and so that the mean weight of newborn girls would still be equal to 6.6. And the alternate hypothesis is that the mean weight of newborn girls differs from 6.6 pounds. And so again, those are the hypotheses. Okay, let's take care of another important point. And this is the fact that sometimes when you're doing hypothesis testing and you're rejecting null hypotheses and accepting alternates, or maybe where you're not rejecting a null and you're stating that things are inconclusive, you can be making an error. So if you think back to the James Bond example, when we looked at the probability that James Bond was going to be correct 65 or more times, and we saw that that was really, really low, what we did is we ended up rejecting the null, and we accepted that he was this person that had a superhuman ability to tell the difference between a martini that was shaken or stirred. Well, couldn't we have been making a mistake? We absolutely could have been. And in other scenarios, maybe you don't end up rejecting, and you should be. And so you could be making mistakes in those cases as well. And so we classify these types of mistakes as type 1 and type 2 errors. And in particular, a type 1 error is when you reject the null when it's true. And if you fail to reject the null when it is false, that's called a type 2 error. And I know this can be really confusing, because it's like, well, how do you tell the difference between type 1 and type 2? How do you keep this straight? And what I do is the following. I look at this and I say, okay, if you reject the null, that ends up being and you're making an error, the way that I keep this straight is I say that that is one word. That's a single word. So this is a type 1 error. But if you don't reject the null and you're making an error, I say that is going to be type 2. That is type 2 because this is 2 words. And so that's how I keep that straight. So a type 1 error is you reject the null, but remember this is an error, so you shouldn't be. Type 2 error is where you don't reject the null, but remember this is an error, so you should be. So if you reject the null when you shouldn't be, that's type 1. If you don't reject the null when you should be, that's type 2. This happens in trials all the time, right? It's entirely possible that, that a defendant goes through a trial and that defendant could be innocent. If a defendant is innocent, but for some reason there's a lot of data that allows a jury to say we're going to reject their innocence, then that jury would be committing a type 1 error if they rejected that person's true innocence and found them guilty. Or in a trial, you could also not reject someone's innocence when you should be. Maybe you didn't have enough information, but the point is that we have to be conscious of the fact that there are errors involved in this hypothesis testing process. And it's important that we have the ability to describe the type of errors that we can be making. So let's take a look at these few examples right here. This first one, I said a test is made where the null hypothesis is that the true population mean is equal to 100, and the alternate is that the mean is not equal to 100 or differs from 100. So if the true value of the population mean is 150, and the null is rejected, is this a type 1 error, a type 2 error, or a correct decision? So the true value of the mean, we're pretending for a minute that we know that the true value of mu is 150. Well, if that's the case, then shouldn't we have been rejecting the null and accepting that the mean is different from 100? Well, that's exactly what happened. It says the null was rejected. So if we should have been rejecting the null and accepting that the mean was different than 100 because the mean is different than 100, then, and the null is rejected, then this is actually a correct decision. So that is an example of a correct decision. Contrast that with this one though. A test is made where the null is that the mean is equal to 18 versus the alternate is that the mean is greater than 18. The true value of the mean is 20. So before we even read any further, if the true value of the mean is 20, should we be rejecting the null and accepting the fact that the mean is greater than 18? Yes, you should be. But look, the null is not rejected. So if we don't reject the null, but we see in the description of this problem, we should, there's those 2 words. If we don't reject the null when you should, that is an example of a type 2 error. And again, going back to the James Bond experiment, suppose we rejected the null, that James Bond was just an average person when it came to predicting martinis, but you shouldn't. So if you reject the null, but you do that in error, so we rejected that null and we shouldn't have been, that is an error, and that is exactly what we would call a type 1 error. Okay, so I'm going to put everything that you've seen with hypothesis testing together now in a couple of examples in the next video.